axons, again, are labeled by N's and sorted by S's. So in this DMSO control nerve at 4 days, we can see that there are several myelinated axons, there are a couple of sorted axons, and Schwann cells are inserting their processes into this unsorted axon bundle in the middle. And when I looked at either ERB inhibited, so by AG1478, or cell cycle inhibited with either acetylcholine that I'm showing here or with camptothecin, I saw that there was a defect in radial sorting. So there is a big reduction in the number of myelinated axons, but there's also this large bundle of unsorted axons, and there's the presence of large caliper axons that would normally be myelinated in a control nerve that are no longer sorted or myelinated in these treated nerves. And we can quantify this defect. So when we look at the number of just sorted axons within a nerve, so any axon that's myelinated or surrounded by Schwann cell cytoplasm, we see that there's a significant reduction in the number of sorted axons in the ERB inhibited or in the cell cycle inhibited nerve, and that when we compare the number of sorted axons in the treated nerves to what the nerve looks like at 48 hours when we're adding the drug, there's actually no real increase in the number of sorted axons from when the drug is added, suggesting that we're completely arresting radial sorting. We also just looked at the total number of axons to see if the defect that we were creating was due to developmental delays or a defect in the axons. And for the ERB inhibited or the camptothecin treated, there was no difference in the number of axons in the nerve. And there was a slight decrease in the number of axons when we treat with acetylcholine, which is perhaps not unsurprising because we're soaking the entire fish in the cell cycle inhibitor, so it's not really surprising that we saw a decrease in the division of neural progenitors. But this decrease isn't really sufficient to explain the radial sorting defects that we're seeing. So at this point I was really wondering how, we know that ERB signaling is required for radial sorting, but how is it regulating this process? It could be, again, as I mentioned, by directly regulating Schwann cell proliferation, or it could be playing a distinct role. And so to get at that, we just compared the two treatments, and if ERB signaling was just regulating Schwann cell proliferation during radial sorting, we would expect the two treatments to look exactly the same. And it turns out they don't. So in the either control-treated nerves or the cell cycle inhibited nerves, we see the presence of Schwann cell cytoplasm within these unsorted axon bundles. But in the ERB inhibited nerves, we never ever see Schwann cell processes within the axon bundle, suggesting that there's actually a defect in Schwann cell process extension when we inhibit ERB signaling. And we quantified this a couple ways. One, I could just count the number of Schwann cell processes that were stuck into an axon bundle, so these guys here. And in the ERB inhibited embryos, we never saw any processes. We could quantify the number of axon bundles present within the nerve, so whenever a Schwann cell process enters a nerve, it bisects this cluster of unsorted axons. So here we've actually got 3 clusters of axons, but in the ERB inhibited nerves, there was only ever 1. And finally, we could quantify the number of axons being touched by a Schwann cell. So whenever a Schwann cell inserts its cytoplasm into the axon bundle, it's able to interact with a lot more axons than when it's just located around the edge of an axon bundle. And so we saw a significant decrease in the number of axons being touched by a Schwann cell in the ERB inhibited nerves, suggesting that there really is a significant process extension defect when we block ERB signaling. We also found, much like in mammals, that ERB signaling is required for the myelination of these nerves. So in those few nerves that did manage to get sorted and myelinated in the ERB-treated nerves, we never saw more than 2 or 3 wraps of myelin around the axons, compared to the 5 or 6 that we normally found in the control nerves or the acetylcholine or camptothecin-treated nerves. However, the Schwann cells were still able to extrude their cytoplasm from these wraps of myelin, suggesting that ERB signaling is only required for the continual elaboration of a myelin sheath, but not for the extrusion of cytoplasm from those wraps of myelin. So what we think is happening is that ERB signaling is required for process extension during radial sorting. The Schwann cell proliferation is also directly required for radial sorting, and that this is in part probably regulated by ERB signaling, but that there must be other signals, because when we block ERB signaling, we only see a partial reduction in Schwann cell proliferation. There is still some that happens, suggesting that other genes are probably required. And we've also found that, again, just like in mammals, that ERB signaling is required for the continual elaboration of the myelin sheath. So I've told you 2 stories today. One, that Schwann cells are required for the relocalization of the lateral line nerve. So it initially goes out within the epidermis, but then rapidly transitions across this epidermal basement membrane into the muscle. And in the absence of Schwann cells, this nerve remains aberrantly localized within the epidermis, and transplanting wild-type Schwann cells back in can rescue the position. And I've also told you that ERB signaling is required for radial sorting to directly regulate Schwann cell process extension, but also probably in part to regulate Schwann cell proliferation. And so with that, I would like to say thank you to all of you for coming and for listening. Will, for being an awesome boss and for doing this on the day after your birthday. Julie Ferlin for her help with the transplants. Dave Lyons, who was the postdoc in the lab, and the second part of my talk was based mainly on work that he had previously done. Tuki Reyes and Chanel Hill for taking awesome care of our fish, and of course everybody in the Talbot lab. My committee members, thanks for coming and for doing this. And John and Lydia in the M Suite, where I spent probably half of my time for the past several years for always taking care of me. So